is Michael Lyons. I'm a chartered engineer. I will bring my own perspectives to bear on this, and thanks very much to the NBCO for having me. I'm coming from the point of view of private practice designers, the challenges that get thrown up to us from the point of view of design and certification and inspections, and having to answer all these difficult questions at the time of construction. And I note at the end that we're going to have a roundtable discussion as well. So a lot of the questions that you're asking yourselves, hopefully we'll come back to those questions, because I'd like to add some comments to the answers as well. And but I'm just conscious of the fact that I need to get through my own presentation. So some of the answers I want to give we'll leave for the roundtable as well. One of the principles behind it is to think in terms of what your strategy for fire spread is. And particularly in the last question, is that if you're not clear as to what the problem is in the first place when a fire occurs, but B, then you can't come up with a strategy to inhibit that fire spread. You've got to go back to first principles to get the correct answers to the questions that you're posing. So the roundtable discussion will have all of that as well, and my colleagues will assist in those answers. So one of the first things I just want to point out is that the whole thing of life safety and fire death rates are actually going in the correct direction. And in my slides, there's a lot of information in my slides, so you're going to be left with them to go back over and read through them after the presentation today. So I would suggest you do that. So I will just allude to a lot of the stuff that's in them and to keep moving given the time that we have. But statistically, Ireland is going in the correct direction, like with a lot of other European Union countries as well, is that over a 28-year period, the death rate trends from 1979 to 2007. And given in mind that our building regulations came in 1992, so that was a 15-year influential period. The number of fatalities due to fire, recorded fatalities, and keep in mind that the fatalities that are recorded are the ones who are dead at the scene. They're not the ones who die subsequently a day or 3 weeks or 6 weeks later. So they're probably higher than what we officially say. But the actual number of recorded fatalities is actually going down, and that we had dropped it by a 50% reduction in that rate, which is very, very significant when you think about it. Now, background to all of it is that we have our National Fire Safety Week, and as David Carroll referred to, is that there's a lot of emphasis on reducing the number of fatalities due to fire, and it's having very, very good positive results, even to the point of that there is now a European approach to it, and there's a European Fire Safety Week that was actually on last week. And the European Commission, while fire safety is a member state competence, the European Commission is looking at ways of developing a pan-European approach, and do pay attention to it. And there's a group called the European Fire Safety Alliance that is organising that whole area. And it's very much complementary to the type of national fire safety guidance that we're promoting as well in this jurisdiction. But the main dominance, of course, in terms of fire fatalities is dwelling fires. Is that the vast majority of our fatality statistics are not in commercial buildings. They're in dwellings, be it dwelling houses or non-dwelling house dwellings. And overall, even worldwide, the statistical information, the feedback is that the fatality rate is reducing all the time, and that's taken from, those statistics are taken from international trends produced in the US and even by the UN. So it is important from our point of view to note that we are actually having a positive effect, and all of the increasing standards in terms of fire safety that have come in since 1992, 1998, 2006, again in 2017, and even the changes most recently in 2020 with open plan flats, that they are actually having a positive effect. And the importance is for us to keep going in that direction. The NBCO set me a very broad smorgasbord of issues to address in terms of fire safety strategies. So obviously in the time that's going, I will be skirting through each of the 5 principal areas, but And it's going to go from means of escape right through the 5 principal issues in terms of fire safety design and fire safety construction, B1 to B5. We have our 2 guidance documents. The Act has evolved over the years, and even the question that there's doubts as to what does or does not need a fire safety certificate. I think that's why it's important for all of us to attend these types of presentations, is that those kind of questions get out and the basis for the answers needs to be understood. We now live in a industry where there's 2 guidance documents, one for dwelling houses and then one for dwellings that are not dwelling houses. It's interesting that the provisions for fire safety that do apply, for a 2-story house, one can jump from a 1st floor window as long as the floor of the bedroom that you're trying to get out of, it does not exceed 4.5 meters off the ground. You can still hurt yourself, but in terms of complying with the building regulations, there is a limit. In terms of the guidance that feeds into the building regulations, there is a limit. And in 1998, we brought in the obligation to have an escape window in all dwelling houses as a upfront obligation. And then in 2006, we reduced the size of the escape window because we're following British standards. And it's just important to note that our guidance is very strict in relation to the fastenings of those escape windows. And it's the details where things go wrong. And I think that's where a lot of building control officers need to pay their attention to, is to be familiar with the actual little details and to insist that there's a positive confirmation that the designer is going to comply with those details. But it's just pay attention to the paragraphs in the different guidance documents, particularly in the dwellings guidance document. If you can't open a window, you can't escape through the window. Just a point, just in relation to the attic conversions, is that the window out of a 2nd floor story is an assisted escape window. There's no expectation that the person is going to jump 6 meters from the eaves to the ground. The intention is that some external assistance, presumably the fire brigade, but it could be your neighbors, it could be somebody in the household themselves, is that the person who is effectively trapped in the attic room, because why are they going out through a window in the roof space if they're not trapped? Their alternative is to go down the main staircase of the house. You would assume that's what people would do. So if they're not able to use the first primary means of escape, they're going to use the secondary means of escape. But it's a rescue window for assisted escape because of the height that the person's going to be, generally anyway, above the ground. And that's why, as Owen referred to, that often forgotten obligation to have that space underneath the window for a ladder. But you've also got to get the ladder into that space. And we've got to be careful with what we allow, is that rear gardens that don't have the facility for a ladder to be brought to the back of a house. You've got to question the means of escape concept that's being applied to the house if you're relying on assisted escape from an attic converted window. As I say, we might have a lot of questions by the time we get to the roundtable talk, so I'll invite any queries that you may have. One of the things that has also changed, particularly since 2020, is that for the first time, we actually have an obligation that there must be a domestic sprinkler installation. We haven't had that before in dwellings. Now, it applies where you've got a 4-story timber-framed house, but it is now in our guidance. Other jurisdictions have brought in domestic sprinklers. Wales, for instance, have done it. An awful lot in North America have done it, but we've been reluctant to start looking at it as an obligation. It has come in open plan flats, and I'll come to that as we go through the other slides. But that whole area of bringing in an engineered solution to deal with shortcomings that are perceived when a fire occurs is available to designers. And building control officers are going to be challenged to agree to those designs going forward as well. It may become an obligation in the future as we go forward, but for the moment anyway, when it comes to domestic sprinklers, it's either open plan flats, elongated escape routes, or for domestic houses, it is timber framed 4-story houses. So one of the things is just the very word dwelling is dwelling house is defined, or is it? It's in the technical guidance, but is it in the actual regulations themselves? What's a dwelling from a legal point of view if it's not in the building control regulations? And what does that mean for us? It's very important to note the definition of flat. I think that's what goes to the answer to the question about the fire safety certificate. A flat is a dwelling that is horizontally separated from something else that's not part of the dwelling. And if that's the situation, automatically you're obligated to get a fire safety certificate. And I can remember when I was a fire officer, the shock on one person's face when she realized that the house that she lived in was actually a flat, legally speaking, because she had her shop underneath her dwelling. And it was no longer it was a dwelling house in the 1800s, but it ceased being a dwelling house when a commercial unit was converted into the actual dwelling house. So it became a dwelling over a shop. Ergo, it was a flat over a shop. People don't like their penthouses being called flats or their duplexes being called flats, but under the Building Control Act, they're just flats. They're dwellings which are horizontally separated. So you get into this thing of compartmentation. And again, that opens up the conversation about strategy, fire safety strategy in terms of design and compliance. And it starts to answer a lot of the questions that people will ask. One of the first things I always advise everybody to do when you start looking at fire safety strategies is to draw out the basic means of escape obligation that are what you're proposing or what somebody is trying to convince you to agree to, is characterize it in a descriptor like that. And that's a 5-story over basement block of flats with a single stairwell and with protected lobbies. There's a bit of a shine on the, can we do anything with the shine, you know? Anyway, but so you've got your enclosed stairwell that goes from ground level here all the way up to the top flat. And then there's a protected lobby box between that single stairwell and a fire in any one of those flats. So your basic strategy is this goes on fire. The fire's got to burn out of this box. It's got to go through your protected lobby, and then it's got to get into the protected stairwell that all the other users make use of. And then the other basic thing to keep attention on your strategy is that your basement is separated from the vulnerable single escape route. Because the fundamental concept in most fire safety design is that there's an alternative means of escape. So I'm presented with a fire, I turn my back to it, I walk away from it. I can go somewhere. But that doesn't work everywhere. You have to end up having single escape routes. So our strategies have got to be able to deal with those. And we're relying on codes, the guidance in codes like BS 5588, which is now withdrawn in the UK, but is still relevant here because it's referred to in TGDB. And the guidance in 5588 has been transferred into the British Standard 9991. But there's issues to do with that standard. And look, in the future, there may be a European-wide standard that will replace all of those regardless anyway. So in terms of the volumes and the guidance that we're following is currently it's Technical Guidance Document B, the prima facie route, Technical Guidance Document B plus 5588 Part 1 is your strategy in terms of fire safety for flats. And in 5588 Part 1 is 1990. It's flats and designs and materials and facilities and complications of apartment blocks and even housing estates have become far more complicated. And the issues that arise, a lot of things aren't mentioned in it. And a lot of designers are using 9991, and a lot of building control authorities are agreeing to allow for it as well, as long as it's used in its entirety. And appeals from Board Pleanála are regularly based on arguments about the guidance in 9991. So there are issues that do arise that have to be addressed. The biggest one, I suppose, really is the 10-meter rule for us, to pay attention to that, is that Ireland has this requirement of compartmentation above 10 meters must be in non-combustible materials. And you can't get around that. That is the Irish state through TGDB saying, this is the standard you must comply with. So you can try to go over to use approved document B or something else to get around it, but in Portlanala hasn't allowed that. For the moment, anyway. So in terms of basic designs, fire occurs in a room. It's got to get out through the doorways. It's got to get into the corridors. You've got to protect your corridors, your stairwells, your entrance hallways. They're all spaces that the products of combustion of a fire. When I mean a fire, I mean fire, smoke, heat, toxic gases, all of the products of combustion. And we deal with it by having these spaces with fire doors to protect the single means of escape. And in terms of specification, in terms of the construction, we have to ensure that what was intended by the test performance of the products is delivered on site. And what has been promised by the manufacturers is able to be delivered by the construction team. Not alone just the design team, it's the construction team as well. And I always point out to everybody is that in the building regulations, it's a twofold obligation. When somebody says that something is compliant with building regulations, they're actually saying it's compliant in terms of design, but then they're also saying it's compliant in terms of construction. It's both design and construction. So if you're agreeing that something is compliant, if you as a building control officer are agreeing that something is compliant with building regulations, you're agreeing that both the design and the construction complies with the building regulations. So it's an interesting clarification just to pay attention to. And then there's all the different fire safety measures, and we probably would be all familiar with it from the combustibility of linings, the surface spread of flame rating, the reaction to fire in Euro speak. It's the contribution that the combustibility of the lining material makes to a flashover occurring in that space is what is being controlled. And the more important the space is to the means of escape, like a lobby or a stairwell, then the greater the obligation is to control the combustibility of the wall and the ceiling linings. So there's a higher standard for its reaction to fire so that it doesn't contribute to a flashover. We require fire-resisting internal walls, the common escape route, fire-resisting walls, fire-resisting floors, all the different systems from detection, emergency lighting, smoke control. And then there's a whole load of ancillary features that have to be specified and agreed that they're going to deliver the ultimate fire safety strategy that is being certified. A whole load of defects that you're going to end up dealing with, and I'm sure we all have our various stories about what we come across. But the idea that in the different photographs you see there is on the left-hand side, it's meant to be a protected stairway, but it's not protected from storage being put on underneath it. And if the storage material goes on fire. Questions over, is a timber stairs allowed versus a material of limited combustibility? Is that what the obligation is? The same when utilities, in the middle photograph, when utilities are put in underneath the stairs. The greater fire load, the greater activity, the greater risk of fire ignition, and its then contribution to interfering with the means of escape. On the right-hand side, the whole thing of party walls and the question there, Owen referred to it as one of the things when the loft conversion is done, what's often forgotten is that when you convert an attic space, you're introducing a new story of fire load. So the party wall that pre-existed must now meet the current obligations to limit fire spread. So the party wall must be upgraded if it doesn't meet the requirements already of Part B. And a lot of the time, the houses or the apartments where an attic is converted won't have fire stopping across the head of the party wall. And TGDB is very, very clear as to how to do that. It gives you 4 options. The 4th one being by test, any other version, as long as it's being shown by test. Now, it doesn't say what the test is, but as long as it's done. So obviously the photograph on the right-hand side with a stepped head of a party wall with your rafters shows that a fire on my side of the compartment here of that photograph will very readily burn into the compartment on the other side. So obviously fire is not inhibited, and that's a breach of the basic intention of the building regulations. When you look at external walls, these are photographs of an external wall cavity space with a concrete slab of the floor in behind, looking through the hole in the wall in the left-hand photograph. And when the wall was opened up, we should have seen fire stopping filling that cavity space. Because on the bottom left of that opening in the hole, you can see a dark shadowed opening. That's a flat. That's flat A. The reinforced concrete floor is the floor between flat A and the flat above it. And to the right of it is actually a protected stairwell. So there's actually 3 compartments where they're sharing the same external wall space. So a fire in flat A very readily could burn up into flat B, can very readily burn laterally into the stairwell compartment, not fire stopped. And then the photograph on the right-hand side is looking in that hole and looking down at the emptiness between the 3 compartments where there should have been fire stopping. And it's a big gap. Easy for fire spread to go. Often we find that small details like fire doors aren't fire stopped around their openings, that people rely on architraves, and architraves aren't a recognized form of fire stopping. And that kind of detail must be confirmed by the construction team that they've finished the fire rating of the wall. There's no point in having a fire rated wall, having a gap and then a fire rating door set, because all that'll happen in the fire is that the heat and the smoke will be pushed through that gap between the fire rated wall and the fire rated door set. So it's important that that gets fire stopped. And sometimes the gap may be 1 millimeter, maybe 2 millimeters. You can take a view on that. But if the gap is 10, 20 millimeters, as you can see in this photograph, that's quite considerable. Much easier for a fire to push its smoke through that gap and then start filling your means of escape, invalidating the fire safety strategy. And frequently, the defect that we keep coming across in apartments particularly is where there should have, where the entrance hallway, the corridor inside the flat was meant to be a protected corridor. What do we mean by protected? It's just a qualifying term to say that it is a lifeboat within the flat. It's a fire-resisting walled enclosure, but it's got to be walled from fire-resisting floor to fire-resisting soffit of the compartment floor overhead, because that's one of the 2 strategies that's allowed in TGDB, is that your entrance hallway is built vertically from floor to floor. The other strategy, of course, is that your entrance hallway wall is brought up to a fire-resisting ceiling that is treated then as a fire-rated cavity barrier, but every ceiling in the flat then, or in the dwelling, then becomes a fire-resisting cavity barrier. Throughout the flat is what the guidance says. So it's the ceiling in the entrance hallway. It's the ceiling in the bathroom where you've got vents. It's the ceiling in the bedrooms, in the living rooms, throughout the flat. So it's the ceilings right out to the external wall, to each of the compartment walls that delimit the demise of that dwelling itself. And that's a big challenge from a construction point of view to get it right, and from an inspection point of view. So the strategy's got to be clear by the design team and by any inspecting persons, be they the assigned certifier, ancillary certifier, or indeed a building control inspector. And in these photographs, you can just see where that gap in the plenum space or the plenum space, however we want to say it, but in the plenum space above a ceiling, is your ceiling part of your strategy too, or is it that the walls of the enclosure are to be brought up to the underside of the compartment floor overhead, as in strategy 1? And you'll often see people using fire-rated foam as a fire-stopping material. And I just say to everybody, fire-rated foam is just like timber. It's not really a linear seal from the point of view of fire resistance. It has a reaction to fire rating, which is the contribution it will make to a flashover, just like timber. But to use it as a fire-rated seal is not appropriate unless it has been shown by test to be able to be used as that. So, and in these photographs, you can see where there's been remedial work done in the middle photograph. Oops, sorry. Where they've put in fire-stopping products between the actual joists of the floor to finish the wall up to the underside of the floor overhead, or indeed to do it from the very beginning to build your plasterboarded stud walls right up to the underside of a slab overhead. So then that what you're doing is that you've done the fire resisting construction and you'll now go to put in your services afterwards, but they'll penetrate your fire resisting wall and you can fire stop that in the letterbox or appropriate position. This is going to bring me to another comment that I'm going to make, and that is that very often the defects occur in fire safety because the fire safety construction is not done first. A lot of people start off with the idea is that they'll start off with the utilities that go into the building and then they'll do the fire safety work around that. Whereas you're far better off starting off with the fire resisting construction in the first place and then build your flat around your fire resisting construction, not the other way around. Most of the defects that we will find from the 2000s and whatever are because constructors left protected shafts till the end. They left their service enclosures until the end. Whereas they're far better off if they build them first and then start fitting in the different penetrations. But we can come back to that and we can chat about that in our round robin talk. Talking about protected shafts, of people put in doors and they don't fire stop around the gaps around doors. These on the left-hand side here is a photograph of a smoke shaft, and this door will pop open if there was smoke in a corridor. So the idea being is that if you have an escape corridor in behind the door, you've got a detector head in the corridor, smoke gets into the corridor, you want to get rid of the smoke out of the corridor. So the detection system sends a signal to an automated door that then pops open and the smoke is able to go from the corridor into a rising shaft like a chimney. But the problem being is that when you open a lower one like this and the smoke rises up through the shaft, and if you're faced with the same situation of where there's gaps between the door frame and the shaft wall, in the upper floors, the smoke that's meant to be leaving the building is going to seep into the corridors up above, and they're going to pop open, undermining completely the intention of your fire door protected smoke shafts. Another thing that arises is that people build their fire resisting services risers, which are meant to be protected shafts, and the walls of the protected shafts are really just built as casings, where you've got a stud with plasterboard on one face, decoratively nice to the outside world, and it looks compliant. But the problem, of course, is the fire is inside the shaft, and the plasterboard isn't facing the fire. And it's a casing, it's not a wall. And it's a misunderstanding of what the guidance requires people to do, the distinction between a 30-minute casing, which is resisting fire from one side only, compared to a full load-bearing structural wall, which is fire resistance in both directions. Both directions are from inside the shaft and in theory from the outside of the shaft, trying to get into the shaft at the same time. Another little pet thing of mine is that of in all common stairwells, there should be 2 handrails. Now, the 2 handrails come in because it's access, Part M. But realistically, everything that gets provided for Part M assists evacuation under Part B. So Part B is relying on Part M being made compliant with. So it's very important that as much as possible of Part M is provided, because it's going to help everybody evacuating under Part B, even though Part B, to my knowledge, Part B remains silent about having 2 handrails. You must have at least 1 handrail to get out of the building on an escape stairway. But the obligation to provide the 2nd handrail, I think, arises from Part M. Yeah, it gets over 1,400, I think, isn't it? Yeah. And most common stairwells aren't 1,400 anyway, unless they're really high. And even then you won't have to worry about it. So just something to note. Now, there's a whole load of standard defects when it comes, that show up when it comes to means of escape. And I've listed a number of them, of that thing of having fire-resistant ceilings that have holes in them that don't inhibit fire spread. Smoke alarm systems not adequate for whatever reason. I'm going to come back to some of the details on it. External walls with cavities that would have either cavity barriers or full fire stopping. The whole thing of finishing our construction so that you deliver and it goes maybe to answer the question that was asked earlier, having a cavity barrier strategy in your design, it's something that's frequently neglected by designers. It's kind of like an afterthought, is that even when fire safety cert applications are made, not showing where the fire resisting cavity barriers go on your drawings is a bad idea, because things like the cavity barrier at the head of a wall are omitted. The cavity barriers or fire stopping at intercompartment floors are omitted. The cavity barriers around window opes, if that's the strategy you're going for, are omitted. It should be clear from the very beginning of your design what strategies you're going for to inhibit fire spread. Technical guide stock or 5588. These are the standard advisory drawings from 5588 for the common areas in flats. And the critical kickoff point is the 11-meter high rule. And there's 2 measurements that are frequently got wrong. Is that when it comes to means of escape, the height that's been referred to as the finished floor level of the occupied story. When it comes to the height of a building, it's the mean roof level. It's not the top occupied story. But for means of escape, it's the height of the finished floor level of the top story. And whether we provide, the strategy is based on providing a common lobby on a single escape route, single staircase. And keep in mind is that, again, the fundamental concept is that there should be 2 staircases. And it's a permitted relaxation to have a single escape route, but you have a single escape route because you do something extra. And that extra is your fire lobby, your fire protected lobby between your single escape route and the compartments that are on fire, the flats. And the only exemption, of course, is that had been allowed in, that didn't come up there, is that of where you've got 2 flats on a small building. And a small building under 5588 strategy is an 11-meter high building to the top floor level. And the simple reason it's called a small building is that the fire brigade can get to it. Fire brigade ladders carried on their engines can actually be brought up to the top window for an 11-meter high building. If you go above 11 meters, their longest ladder that they can physically, if they can physically get it in. I only know, by the way, of 1 county council that's ever asked about fire brigade firefighting ladders up front. It was Monaghan. But they insisted on being told that fire brigade firefighters could get a ladder up to the outside of the building. Everybody else presumes you can. But if you don't put it into your design documentation, people are going to forget about it. But the 11-meter rule comes from the idea that the 13.5 ladder, which is at a slope, is able to be put up to the outside, to the topmost window, and the fire brigade can get up to that window where somebody might be stuck in their flat and take them out of their flat. Very basic, simple strategy. So the layouts of open plan is the biggest innovation that we've had since 2006, allowed in 2020, provided that you provide a domestic sprinkler system. Now, open plan flats were allowed as bedsitter type flats as long as the travel distance was less than 9 meters. So, but the big innovation is to have bedrooms which are inner rooms. We haven't had that before. But the only reason it's allowed is because domestic sprinklers must protect the escape route from the inner room bedroom to the front flat entrance door. And there's a number of other obligations. You must provide an LD2 smoke alarm system. You must keep it a certain distance away, 1.8 meters. The overall travel distance can't exceed that dead end of 20 meters from the furthest point of the flat to the front entrance door. So they are significant, the other obligations. The other thing that has been allowed is extended corridors. And the simple rule of that single dead end escape route, you can't turn your back on the fire. You've got to keep going in one direction. And the old route was you had a dash distance from your flat entrance door through a lobby to the stairwell of 4.5 meters. Simple idea being if there's smoke, someone's flat goes on fire, they open the door, smoke comes out, gets into the protected lobby, they close the door because it's a self-closing fire door. You open your flat entrance door and you're faced with a little bit of smoke in the lobby, but there's only a short dash distance of 4.5 meters to get out of the protected lobby. That can be lengthened to 7.5 meters if you put in a big whopper of an AOV, an automatically opening window vent, 1.5 square meters. And in 2020, we extended that distance to 15 meters. But we extended it provided that you still have your AOV on your 15-meter common corridor, but now your neighbor's flat and your flat must all have domestic sprinkler systems. And that's a big change and very welcome change, we'll say. So second thing I just want to comment on is this thing about Part F and the challenges that Part F throws up. And I'll go back to the point that I said is that the first thing that should really be there is you build your protected enclosures, be it your protected stairway, your protected entrance hallway first. Then you fit your ventilation system around that. Fire safety comes first. You're going to want to duct your warm air around a dwelling, fine. But if you're going to try and go through the fire-rated enclosure for means of escape, it comes first. And you try to avoid going through that protected enclosure and treat it like that it's the protected lobby. One of the things that's very important in complying with Part F and Part B is that the design team needs to integrate A, obviously, for structure, materials and workmanship. But F and B need to work together from the very beginning. They need to agree an integrated design. And I would say is that the first place to start is do your fire safety enclosures first, then fit your ventilation system around that or through it. But it certainly needs to be considered because you're going to penetrate the fire resisting enclosure. There is a lot of guidance available. 5588 Part 1 does talk about ducted warm air systems, again on the principle of don't penetrate the enclosure, and if you must, there are serious limits on it. Technology has moved on. Fire alarm activated smoke dampers are now available. It makes your ducted air system a whole lot more expensive if you're going to try to go through these enclosures. So if you can avoid it, but there are solutions to doing it. But they're all triggered by your smoke alarm system. So your smoke alarm system starts to become very, very important. And Irish Standard 3218 is the national standard for fire alarm systems, primarily for commercial fire alarm systems, but it now includes a section on domestic smoke alarm systems as well. And the standard for us has gone to LD2. And LD2 is life domestic, level 2. Every room has a detector head, more or less. And a big change that we made in 2019 was that every bedroom must have a detector head. Now, it took from 1992 until 2019 for it to be clearly, categorically laid out that a bedroom must have a detector head in a dwelling, in flats, certainly. It was inferred in dwelling houses. But it took quite a while for people to realize that detection is really important. Getting people out of the place that they're in is the primary purpose of fire safety standards. And warning people to leave, whether they leave or not, of course, is another argument. But we've gone from standalone domestic smoke alarm systems originally in 1992, or not even a system, just a fitting, to an interconnected LD2 smoke alarm system, intending to wake everybody up. What's very important is that they're properly certified. And there is a pro forma certificate in IS 3218 for domestic smoke alarm systems. And every such system should be designed and certified as being installed in accordance with IS 3218. It's not that complicated to get it right. It's a consumer unit connected system. And the two certificates that are available for the handover at installation and then the annual servicing one. And that should become the norm. And I can remember when there was massive arguments, and the bottom right hand photograph just refers back to that time, of developers saying is that we only need to install really one detector head, standalone battery one, on the ceiling of the landing, and there's no need for one at the ground floor. And that was an argument that people were making 20 years ago. We're now at the point where every single room in that house, including both landings, are required to have a detector head fitting, all interconnected. So you're asleep in your attic, and it goes back to the comment about the habitable, non-habitable storage attic conversion. I don't believe a word of it. They're all bedrooms. I've yet to go into one and see that it's not a bedroom. But people put the most precious people in their lives, their children, into these attic conversions. And you're up in an attic conversion and there's a fire in your utility room. The only thing that's going to warn you is this LD2 system. So if they're not getting that right, everything else is meaningless. Fire stopping, cavity barriers. If you don't warn people at the most vulnerable location in their dwellings that there's something wrong close to their fire exit door out of the dwelling, we're getting it wrong. So when it comes to apartment blocks, the Type M system the manual fire alarm system is an obligation, a minimum obligation. It is practice in this country that you provide an L3X, which is every flat is interconnected commonly with a heat detector head inside the flat. And that's what 3218 looks for. Now, Technical Guidance Document B is a little bit more forgiving when you've got non-combustible floors, but the general practice is for, certainly most fire officers will look for an L3X system. I, as a designer, will just automatically want my client to put in an L3X system. Technically speaking, if they have non-combustible floors, TGDB lets them off the hook and they have to put in a Type M system. Now, the fire detection alarm system might have to do other ancillary activities like pop open smoke vents. So they've got to provide detection in the common areas so as to pop open smoke vents. But TGDB at the moment does allow for common areas of apartments and not to have an L3X system if they have non-combustible floors. Keep an eye on that. I reckon within the next 10 years, certainly after the Grenfell Tower report gets done, I think that there will be general perception that you will have to provide. And I think most insurance companies want there to be common detection systems as well. So I think it behoves everybody to pay attention to that. Very important elements of the 3218 provision is to have a cause and effects matrix. There has to be a design document that looks at why the system is going to be set off. And when the control panel gets a signal, what does it do with that signal? It sets off sounders, it flashes lights, it pops open smoke vents. But that's a design document that should be given to building control, the cause and effects matrix. And it's clear in 3218 that it has to be done by the design team. And then there's a suite of certification that goes along with all of that as well. Then just a word in relation to alternative means of compliance. There's a plethora of codes of practices in relation to systems and various systems. But when it comes to alternative compliance approaches to Technical Guidance Document B, is that the vast majority of buildings don't require, well, probably don't warrant going anything different to Technical Guidance Document B and a suite of codes of practices. But there are buildings which do benefit, tall and complex buildings benefit from having an alternative approach. And TGDB does refer to the American code, the NFPA code, the CIBC guide, but primarily to the British standard 7974. And 7974, while it is a British standard, it's internationally recognized as an alternative approach to prescriptive design, which is Technical Guidance Document B. But as an alternative approach, it requires the designer to do an awful lot of groundwork. And all of that information has got to be collated to do with, they've got to recreate the entire fire safety picture that you take for granted with Technical Guidance Document B. And they've got to interrogate the design to come up, to develop a strategy. And they've got to answer all the issues like the fire science of fire loading, the reaction of the building, the means of escape, the evacuation of the building, fire brigade intervention, put it all together in a package of information, review it, agree that it comes up with the same, meets the building regulations. Building regulations don't change. B1 to B5, still the same, irrelevant which code you're using to comply with it. The legal obligation is B1 to B5. The legal obligation is not to comply with Technical Guidance Document B. That's one way of complying with it. 7974 is another way of complying with it, but we're very lucky in this country. You've got to get a fire safety certificate. So there's Sarah and her colleagues and David Carroll have got to be convinced by your 7974 solution that you're coming up with the equivalent of Technical Guidance Document B. And you've got to go through the hoops, and you can, the details of it for today aren't all that important, but there's a big design process to go through to assess your design and to come up with the same outcomes that you would have come out with if you complied with Technical Guidance Document B. Because the outcomes are to comply with the building regulations, Part B. So it behoves the designers to come up with some very, very good, technically convincing data to show that they have the same level of fire safety achieved. And it has been done. It's been done internationally. Here's a couple of photographs of different buildings where it's been done. Particularly, I like the Gherkin in London. That's a particularly nice one. And those ones, the structure is on the outside of the building. Very complicated, open plan. A lot of them rely on sprinkler systems, on very innovative smoke control solutions to keep the fire away from the evacuating people. But they are available to us. And then just the last thing I'm just going to talk about and mention is this thing of materials used in high-rise apartments. I've quoted the chairperson of the Grenfell Tower inquiry, Sir Martin Moore-Bick, and he just pointed out in the first phase report about that there was compelling evidence that they didn't get it right when they looked at the materials they were using in the refurbishment of the tall building. And not only that, they knew that they weren't getting it. Some elements within the design and construction team knew that they weren't getting it right, but blazed ahead anyway. Now, that's frightening. Now, why is it important to us? It's important to us because there's problems ahead. There's problems ahead with complying with Part B of the building regulations. And there's problems ahead with going through Technical Guidance Document B, because the guidance in Technical Documents B goes back to 2006 when it comes to having these conversations. And a couple of things just to remind everybody of is that the photograph of the Grenfell Tower on fire, it's 24 stories high, relying on a single staircase. So you're up here, you have one way to get out of that building, one way to get from up there all the way down, because jumping out is not an acceptable solution. And it was too high for fire brigade vehicles. The general thing with the fire brigade is that they have a small ladder, they've got a 10.5 ladder, and their biggest physical ladder that it can physically carry is 13.5 meters. That's the 11-meter rule. They then have other high reach appliances, but they only reach so high as well. So you're very much relying on the fire safety strategy for the tall buildings to get them right. And the tall buildings go wrong when you use the wrong materials. And that's why there's significant restrictions on the materials that go into tall buildings, because your single escape route, you are really vulnerable in a tall building. And I've mentioned about the standards for the 10-meter rule, that you have to have non-combustible construction. Another one that's missed is anything, if you have a story that's above 10 meters, all your compartmentation materials in the walls have to be materials of limited combustibility. Timber is out. Plasterboard's allowed because it's a material of limited combustibility. The paper on our plasterboard, unfortunately, means it can't be classified as a non-combustible material. And just the last word I just want to make a point of is Technical Guidance Document B, like approved Document B as well in the UK, relies on a classification system and a fire testing system. And the current version of TGDB refers to a report called BR 135 1988. BR 135 1988 was the first edition. It was this is for external wall, the combustibility of facades, particularly rain screen facades. It was replaced by a second edition. It was replaced by a third edition. And only last year, the publishers of it, BRE, have separated themselves from the British Standards Institution on the guidance that they say. And they now say you must comply with the BS standard and be very careful relying on and interpreting the extrapolation from somebody passing the BR 135 system, all because what they've realized what they were doing as a result of Grenfell. When you do a test and you've passed these codes, the test tests your rain screen cladding system on a 9-meter high wall. There's no window openings. So tell me any apartment block that has a 9-meter length of wall with a fire burning on the outside that doesn't have a window opening. So when you're if you're on the design team, you make sure you talk to your fire safety consultant before you approve anything. Because you might find that just because the guidance document from 2006 says something, circumstances have passed it by. And you've got to find out whether that's still relevant for you to accept it or not. And on that, I will just keep in mind Grenfell Tower and the lessons learned from it. And I would advise everybody to listen to the Grenfell Tower inquiry videos on YouTube. Very, very informative.